And welcome to our bonus features segment. We've got some anomalous electron contents once again. This is the total electron content forecast. You can see those red blobs there showing up at nighttime. So some anomalies happening there, some likely GPS errors in some unlikely areas. We'll let it play through one more time. The total electron content is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And your GPS satellite's located at about 12,500 miles of altitude, just on the inner portion of the outer Van Allen belt. Here's a diagram of what you're looking at. And again, your GPS satellite is located at about 12,500 miles of altitude. Space Weather Enthusiast dashboard showing some internal charging hazards here, caused by high energy electrons making it into the internal circuitry of satellites. So we could see some minor communications breakdowns as a result of those internal charging hazards. Electron flux at high levels here. And we got to even higher levels than NOAA forecasted. That's the 3-day chart as measured by the GOES 16 and 17 using their radiography from their geosynchronous orbit. They measure it at the F-ionosphere layer. And there is the forecast model. NOAA expecting a reduction in electron flux here. I think in the coming day we're going to see about similar levels up here. So that's the forecast. That's my little tweak on the forecast. Here's the 1-year chart from Solon.info of the electron flux. That's your greater than 2 mega electron volt electron fluence. We'll also show the vibrational frequency of the F-ionosphere layer, the bridge between Earth and space. So this is the vibrational frequency, or ionogram. We are seeing some anomalies here. We'll show the anomalygram to clear that up for you after that plays through. So there's the anomalygram, and you can see some much more significant swings here in ionospheric anomalies. So some high-frequency anomalies showing up there in dark blue. That's anomaly in megahertz from the 30-day median. The dark blue is 3 megahertz above the 30-day median. The dark red is 3 megahertz below the 30-day median. And we'll show the latest image as we do most days. So there's the latest image ionogram. That's 1300 universal time. There's the latest image anomalygram, 1300 universal time. Here's the latest intensitygram and the latest solar magnetogram. Likelihood of solar flare is very high, especially from this group right here. As it approaches the southwestern limb, its likelihood to produce a major flare is much higher. We've got about 8 named sunspot groups at the moment. Likelihood of solar flare is very high. Likelihood of coronal mass ejections similarly high. Let's bring up a composite view here before we close out our daily space weather content. This is multiple wavelengths here. Ionized helium in 304 angstroms, ionized iron in 211 and 171 angstroms. A 3-way composite. Just keep in mind that this shows the imagery. 211 angstroms is normally like a purple color. It's actually green on this one. The ionized helium, 304 angstroms, is red as usual, and the 171 is blue instead of gold on this composite. That's yesterday and today, and it's about time to close things out. So thanks for tuning into the Smash News Network, Least Busted Damon News, and we'll see you soon. In the meantime, may that solar wind be at your back.